Hi everyone, here we will see chopper control DC drives. So this is called DC to DC control drives. It is operates on DC supply. So chopper control DC drives are DC to DC converter operating under certain conditions. The use of such converter is extensive in automotive applications, but also in case where a DC voltage produced by rectification is used to supply secondary loads. So here secondary loads when DC voltage is required. So those conditions these type of chopper drives will use. The conversion is often associated with stabilizing, that is, the input voltage is variable but desired output is always stays the same. So when input voltage is variable, the output will be constant. So DC to DC, that is chopper, is a uh, variable voltage to convert into fixed voltage. So input is variable DC and output will be fixed DC supply. The conversion is also required to produce a variable DC from fixed or variable source. The issue of selecting component parameters and calculating the performance of the system will be addressed here. So we will see the calculation performance of the chopper drives we will see. Since these converters are switched mode system, they are often referred to as choppers. The basic circuit of this converter is shown in figure. First, to a purely resistive load. So if you remove the low pass filter as shown in and diode, the output voltage equal to input voltage. When switch is closed and to 0, when the switch is open, the output voltage V0. When switch is closed, the output voltage is 0. The switch is open, the output voltage equal to V0. So Ts equal to D, that is the duty ratio. So why we are using filters here? To eliminate the ripples in the output voltage. The low pass filter attenuates the high frequencies and levels almost only the DC component. So here low filters are used to eliminate the switching operation, that is ripples waveforms, right. The energy stored in the filter inductor, that is the load is inductor, has to be absorbed somewhere other than the switch. Hence the diode which conducts when the switch is open. When switch is open, the output voltage is V0. When switch is closed, the output voltage is 0, right. So when open circuit, the diode will conduct and the output voltage is V0, right. The current to the inductor levels never becomes 0. As switch is open and closes, the circuit assumes one of the topologies, right. So if the source of supply is DC, a chopper type converter is the basic operation of single switch chopper and drives, where it was shown that the average output voltage could be varied by periodically switching and battery voltage on and off for varying intervals, right. The chopper drives periodically switching the battery voltage on and off for varying intervals. The principal difference between the thyristor controlled rectifier and chopper is that in the former the motor current always flows through the supply, whereas in the latter the motor current only flows from the supply terminals for part of each cycle. So supply current how it will flows, right? A single switch chopper is using a thyristor or thyristor MOSFET or IGBT can only supply voltage positive and current to DC. The motor is therefore restricted to quadrant 1 motoring operation. So this is about chopper controlled DC drives. Okay. Okay, thank you everyone.